So on number 7 on your notes, first we would factor. Now I'm going to go kind of fast with the factorings. If you want, you could always use the program on the EOC. But the factors of 1 that add up to -2 would be -1 and -1. And then what about x squared minus 1? We just did one of those over there. X minus 1, x plus 1. Now, in order to subtract two fractions, the denominators have to be exactly the same. They have to be common, right? So, right now, they are not exactly the same. Now that we've factored them out, it's pretty easy to compare them. What is this denominator missing that this one has?
Plus 1.
Yeah, so watch what I do here. It's going to go, I'm going to multiply an additional x plus 1 on the top and on the bottom. So if you multiply the bottom times a factor of x plus 1, you have to multiply the top by a factor of x plus 1. Now you can't just take something away. The way we fix it is we multiply them to be the same on the bottom. What is this factor, or what is this fraction on the right missing that this one has?
Another x minus 1.
Another x minus 1. So this one needs to be multiplied by x minus 1 on the top and on the bottom. So do the denominators match now?
Yeah, correct.
Yeah, they do. So let's go ahead and FOIL out the top. So what's the numerator of this one going to be? X squared plus 1x. Good. All over. But now that the denominators are common, do they really matter anymore? No. What's a shorter way of writing x minus 1 times x minus 1 again? Yeah, so we can shorten that up so it's less to write. That'll be x plus 1 times x minus 1 squared would be our common denominator. Minus subtraction sign, and then we would distribute again. So x squared minus x all over the common denominator of x plus 1, x minus 1 squared. Now that the common denominators are common, what do? We do this minus this, right? Subtract across the top. So if I gave you that first semester, x squared plus x minus something else, in this case x squared minus x, what do we have to remember to do?
Foil?
No, it's not foiling, it's subtracting.
Yeah, to
Distribute, yeah, you might think, yeah, is that what you meant? So this actually ends up becoming x squared plus x minus everything that comes after it. So minus x squared, but the fact that this is a minus and it's being subtracted actually makes it a positive x. So be careful of that. Everything that comes after a minus sign, even if it's not a parentheses, it's assumed that you're subtracting everything after it. So what does that whole numerator come out to?
2x.
Yep, it's 2x.
And what's the x?
All over the common denominator. And that would be it. Okay, and remember the x cannot equals, that's our excluded values, because what number can never be on the bottom of a fraction?
0.
0. So what number would you plug into the denominator and it would cause that factor to be 0? We have a couple answers here. -1, right? Because if you -1 right here, -1 plus 1 would be 0. That's a big no-no on the bottom of a fraction. But what about this factor? 1 minus 1. So x cannot be 1 or -1 in order for us to have a good answer that's not undefined. All right, and then our last one here for number 8, for adding, we have one adding and we have one subtracting. So the denominator is currently made up of 3 different things. Well, this one's just an x, this one's an x plus 1, and this one is an x minus 2. So, what is the first one missing that the other 2 have?
Oh,
Now remember, they're multiplied together.
plus 1.
So you can't just add 1 to the top and the bottom. That doesn't work. You have to multiply an entire factor. Right? Because if you think about it, 2/3, if you just add 1 to the top and the bottom, what do you get? Is 2/3 the same thing as 3/4? No, you can't add. That doesn't work. You have to keep it proportional with multiplying, like a ratio. So what does this first denominator need that it's missing? It's actually two things. It needs an x plus 1, and it needs an x minus 2. So if there's 3 different denominators, your common denominator is going to have 3 different factors. So unfortunately, this is going to be an x plus 1 and an x minus 2 on top. What is the second denominator missing that the other two have? An x, and an x minus 2, exactly. So this needs to be multiplied by an x and an x minus 2, which that'll be easier to do. That we don't have to FOIL that. And then the last one is missing an x and an x plus 1. An x and an x plus 1. So now your common denominator is made up of those 3 factors, the x plus 1, and the x minus 2. And then we have a plus, so we're going to have 3 of these, so that's exciting. And then this last one is subtracted over x times x plus 1 times x minus 2. So the last two are actually a little bit easier. If I distributed this through, it would just be 4x squared plus 4x. And then this middle one here, if I distribute this through, it would be 3x squared minus 6x. Now, we just need to FOIL this whole thing out right here. So I'll just pull it down here. It's 2 times x plus 1 times x minus 2 is what that whole numerator was. So I'm going to leave the 2 out front and go ahead and FOIL these out. So that would be x squared minus x minus 2. Because the negative 2 plus 1 would combine. And then if I take the 2 through, that would end up being a 2x squared minus 2x minus 4. Okay, now finish it out yourself. Add the first 2, and then from that subtract the last numerator. Okay, go ahead and finish that one. Add those together. 5x squared minus 8x minus 4. And then from that, we need to subtract the last polynomial over here would be 4x squared plus 4x. So minus 4x squared plus 4x, you need to subtract both of those things from the first half. So this would actually end up being 5x squared. Oh no, sorry. It would be the 5 up front and minus the 4 in back would be just 1x squared. And then the negative 8x minus 4 more x's, and we're distributing that negative to the 4 would be what?
Negative 12.
Negative 12 x's, and then the negative 4 right there. All over the common denominator of x times x plus 1 times x minus 2. And that is your answer. The top doesn't factor. There's no factors of 4 that add up to 12. What are all the numbers that could not be on the bottom of that fraction? Negative 1 wouldn't work. Good. 2 wouldn't work. What about that one?
X, well, 0.
0, yeah. If you plugged in 0 for x, that would be a 0, and 0 times everything else cancels everything else out. So if there's a single x, that's a 0. Okay? All right, the last thing we need to do, we need to solve equations. Okay, so the first one, I'm starting off with kind of like a little practice EOC multiple choice. Now, not everything on the EOC is multiple choice, but a problem like this, there's a real good chance it could be. So it says, identify the solution to the following rational equation. And it gives you this big, ugly equation with lots of x's. But they do give you 4 options. Okay? So I want you to take about 3 or 4 minutes and see if you can kind of wiggle around and figure out which one of these would be correct. If you're still confused on this one, you could just literally do alpha y equals and type this stuff in. So we know that the correct answer is 2. So if I'm plugging in 2 for x, that would give me 2 over 2 minus 1 is 1. Minus, and then do another alpha y equals 3 over, once again, we're plugging in 2 for all the x's. So that's the left side of the equation, right? And then you can just plug in the right side of the equation. So that would be alpha y equals 1 over x, oh sorry, no x. X is 2. So 2 squared minus 2, which you should know is 2. So 1/2 is the same as 1/2. That makes the equal sign true. That's the whole point of an equal sign, is the left side is the same as the right. All right. This is the most obvious problem I will ever give you. You should be able to look at it and immediately solve it. What is the correct answer?
2.
X equals 2, right? It's kind of like this. It's kind of, we did this before. Let's say I have log of x equals log of 2. In order for this equal sign to be true, what does this x have to be?
2.
Yeah, so it's really obvious. If there's 1 log on one side and 1 log on the other side, the stuff inside has to also match. It makes sense, right? Well, the same thing works here. If there's a 3 on the bottom of this fraction and there's a 3 on the bottom of this fraction, then the tops have to be equal to each other, right? So therefore x equals 2, okay? But what if it's not as obvious? Like, you can't just look at this and be like, oh yeah, x is this number. Do you guys remember back to maybe 6th grade? Yep, there it is.
That was my favorite.
Yeah, how do we solve a fraction equals a fraction? Yeah, cross multiply. I think some of your teachers call it the butterfly or something like that. So what is x times 3, or 3 times x? 3x equals, yep, cross multiply the other way is 14. Divide by 3 to get x myself, right? Divide out by 3. Divide by 3, which that makes sense why it wasn't very obvious because it's a really ugly answer. But 14 thirds, you could get a decimal if you want, but probably a fraction is better on the ESC. 14 thirds will be your answer.
7 common denominator.
You can do that, and then the numerators would be equal, just like the, yep, that
And you have
works.
to divide by the number you multiply by.
Okay, what about example 4? What would I do?
Well, you just
Foil.
x plus 5 equals 7.
What?
Because the bottoms are the same, you don't have to do anything.
Good. There's kind of 2 scenarios. If the bottoms are the same, do we need to cross multiply?
No.
No. We would just set the tops equal, right? So x plus 5 equals 7, therefore x equals
2.
2, right?
But does that work on the bottom? Because then you have 0 on the bottom.
You're correct. It says check your answer. What does this mean? So if I take the number 2 and I plug it back in, what do I get? 0. So the one and only answer that I got doesn't work. That means it has no solution. Okay, number 5. Are the bottoms exactly the same?
No.
No, so I would cross multiply. So this is pretty easy. 8 times x minus 1. What is that going to be?
8x minus 8.
8x minus 8. Good. You have to distribute that 8. Equal sign in the middle. And then what is 2 times 3x minus 2?
6x minus 4.
6x minus 4. Now we teleport back to algebra 1. So I subtract this 6x over. That would be 2x. Add this 8. So that would give me 4. Divide by 2. X equals 2. Now be careful. Check your denominators. Does that cause a 0 in either fraction on the bottom?
No.
No. So we're good to go. That means we can circle our answer and it has a real solution that works. Let's do example 6 and I'm going to skip number 7. Go ahead and do example 6 on your own real quick. So here's my first step. Hopefully you did the same thing. You might have just gone ahead and done the foiling or distributing. But we cross multiply here. That will give us x squared plus 5x equals x squared minus x minus 6. What happens when I try to combine my x squareds? Yeah, if I subtract that over because it's a positive 1x squared, they both cancel. So that makes it easy. That takes the quadratic aspect of it away. So now I'm just going to add this x over. That gives us 6x equals negative 6. Divide by positive 6, right? To get x by itself. Therefore, x equals negative 1. Does that number work? Yeah, you can plug in negative 1 into either of those denominators and they are good to go. So that's your one and only answer. It works. That is how we solve rational equations. Okay?